Good morning, sir. Good morning to everyone. Myself, Keerthi from CSM department. I'm here to give the presentation about the future trend deep learning based clustering. Introduction to deep learning based clustering. Deep learning based clustering combines the traditional clustering techniques with the neural networks. This approach enhancing the ability to identify the complex pattern in the high dimensional data. The integrations of the deep learning is the transforming how we understand and categorize the data. Evolution of the clustering techniques. Traditional clustering methods include the k-means and the hierarchical clusterings which have limitations with a non-linear data. Deep learning has introduced algorithms that can automatically learn feature representations for better clustering. This evolution is pushing the boundaries for data analysis and the pattern recognition. Applications in image processing. Deep learning based clustering is making significant shifts in the image segmentations and the classifications. Techniques like convolutions and neural networks are used to clustering images based on the learned visual features. This has the implementations in the field such as medical imaging and autonomous vehicles. Advances in the natural language processing. Clustering in the natural language processing benefits from the deep learning through the word embedding and the semantic analysis. Model like a breed and GPT enabling the clustering of the text data based on the conceptual meaning. These facilities applications such as topic modeling and the sentiment analysis. Handling big data. The rise of big data represent challenges that are traditionally clustering method struggling to address. Deep learning based clustering can efficiently process large volumes of unstructured data. By learning distributed computing, these methods can scale to meet the demands of the big data environments. Unsupervised versus supervised learning. Deep learning clustering methods can operate in both unsupervised and the semi-supervised setting. These flexibilities allows for the integrations for labeled data to improve the clustering outcomes. Such hybrid approaches are becoming the increasable popular in the data science. Integrability challenges. One major challenges with the deep learning models is their lack of interpretability compared to traditional methods. As a clustering become more complex, understanding the relational behind the grouping in the crucial. Ongoing the research is focusing on the developing techniques to enhancing the interpretability of these clusters. Emerging the architectures. New architectures such as a variational auto-encoders and the genetic adversarial networks and influencing the clustering techniques. These architectures can model complex data distributions leading to better clusterings. As these technologies evolve, they are expected to reshape clustering methodologies. Hybrid clustering approaches. Combining the deep learning with the classical clustering techniques is a gaining the attractions. Hybrid methods leverage the strength of both approaches to improve the clustering accuracy. This trend is leading to more robust models that can tackle diverse data sets. Transverse learning in the clusterings. Transverse learning allows model trained on one data set to the adapted for the clustering another data set. This reduces the need for extensive labeled data in new domains, making the clustering more accessible. It is particularly useful in a scenario where data is scary or costly to obtain. Future research directions. Future research will focus on improving the scalability and the efficiency of deep learning clustering algorithms. There is also a need to enhance the interpretability and accountabilities in the model outcome. Exploring the new applications and the interdisciplinary approaches will drive innovations in this. Clustering in the edge computing. Clustering is becoming the increasable relevant in edge computing, where data is processed closer to the source. Deep learning based clustering can enable the real-time data analysis and the decision making. This is the particular useful in the IoT applications and the smart devices. Ethical considerations. The use of deep learning based clustering raises ethical concerns regarding the data privacy and the bias. Awareness and the mitigations of a bias in the clustering models are crucial to ensure the fair outcomes. Developing ethical frameworks for these technologies is becoming the increasable important. Industries adoption trends. Numerous industries, including the healthcare, finance, and the marketing, and the beginning to adapt and deep learning based clusterings. Organizations are leveraging these techniques to gain the insight for the complex data sets that were previously usable. These trends indicates a growing reliance on AI-driven analytic of strategies decision making. Conclusion for this: deep learning based clustering is a poison to revolutionize how we analyze and categorize data. As technology advances, the integrations of these techniques will become the more seamless across the various domains. The future hold existent possibilities for innovations and discoveries in the data clustering. So thank you for giving these opportunities, sir.